In this episode of Remote Trigonometry, we will be doing an example involving vectors. Here we have a situation where we have two forces pulling on an object. One is 200 pounds of force at 75 degrees from the positive x-axis, and the other force is 170 pounds at 19 degrees above the negative x-axis. Suppose we want to keep the object that's being pulled fixed, like we want to keep that object at the origin. If we left it as it is, force 1 and 2 are going to pull it away from the origin. If we wanted to leave it fixed, we would have to act on it with a third force that is pulling sort of in the direction I've indicated here. So our task is to find what magnitude and angle we would have to adjust that force to keep the object fixed. So force 1 has an x-coordinate of 200 times cosine of 75 degrees and y-coordinate 200 times sine of 75 degrees. That's approximately an x-coordinate of 51 and a y-coordinate of 93. And then force 2 has an x-coordinate of negative 170 times cosine of 19 degrees and then 170 times sine of 19 degrees. Notice that we're measuring not from the positive x-axis, but still magnitude times cosine of your angle when it's measured from the x-axis is going to give you your x-coordinate, and magnitude times sine of the angle is going to give you your y-coordinate. But just remember to indicate that the x is negative due to the quadrant. And those values are approximately negative 160.7 and 53.3. Okay, so if we added those two forces together, we would get negative 108.98, so approximately negative 109. And that would be the x-coordinate of their sum. And then the y-coordinate of their sum is approximately 248.5. So those two forces together are pulling in the x direction 109 pounds, but it's in the negative x direction, and the y direction 248.5 pounds. Our third force is going to have to counteract that. So we already know that our third force is going to have an x-coordinate of positive 109 and a y-coordinate of negative 148.5. Okay, so we already know what our third force is. That's its terminal point. But we want to find the magnitude of it and the direction. So the magnitude is going to be, following the Pythagorean theorem, the square root of 109 squared plus, it's technically negative 248.5, but because you're going to square, you don't really have to put the negative. And that gives us a magnitude of 271.4 pounds approximately. So that third force is going to have to pull at 271.4 pounds. Now to find the angle, why don't we measure it from the positive x-axis, and we'll indicate it once we figure out what it is. So that angle has an opposite side of this y-coordinate and an adjacent side of that x-coordinate. So if I take inverse tangent of opposite 248.5 over adjacent 109, I end up getting 66.32 degrees. And so it would have to pull 66.32 degrees below the x-axis at a magnitude of 271.4 pounds to keep that object fixed. That's kind of a classic vector problem in which you're analyzing how the different forces interact with each other. And that wraps up this little episode.